So I think with that intro, and I'd like to get into the next, the second segment of this interesting webinar, which is basically trying to, present the findings from very empirical studies on farm ponds. Try to give us a big picture. So a big picture view of farm ponds in Maharashtra and its impact. We have about 3-4 presentations, and they are going to be very short presentations. The first one is by Ankita Yadav and Sarita Chemburkar, and they are going to present, and the title is A Deep Dive into Farm Ponds in Maharashtra, the Intended and the Actual. So this is basically scenarios from 6 villages where they did a very in-depth studies and things. So both Ankita and Sarita are young geologists and researchers in the WOTR Centre of Resilience Studies based in Pune. So I think each of the, all the presentations will be about 10 minutes each, so that we have some time later for discussions and things. So over to Ankita and Sarita.
Thank you, Joy sir, and good afternoon, everyone. I'm Ankita Yadav from W-CReS. Today, with my colleague Sarita Chemburkar, I'm going to present our study on different scenarios of farm ponds in 6 villages of Maharashtra. We are aware that state of Maharashtra is facing frequent droughts and drought-like conditions, erratic rainfall, and elongated dry spells in many regions of Maharashtra. These climatic externalities are putting tremendous pressure on agriculture productivity as well as on agrarian community in terms of monetary income. In order to cope with the challenging climatic scenarios, state government has been putting their best efforts to support agriculture and agrarian community to help elevate farmers' quality of life. Farm ponds are one of such mitigation measures proposed by state government of Maharashtra early since 2009, and even before that, as mentioned by Dhaval sir. So what are farm ponds? Farm ponds are traditionally the water harvesting structure, as Sashi Shekhar has very nicely elaborated earlier. And these structures are meant to be capturing the surface runoff water, and this water is used as a protective irrigation during dry spell. These ponds are being observed across the country in different sizes and shapes. Their design purposes as well as the type of usage also vary in different geographies. With the objective of drought mitigation and at the same time to increase farmers' income, state and central government has farm ponds in Maharashtra through various subsidized schemes. The main purpose of farm pond is to provide protective irrigation during dry spells, and also to reduce climatic vulnerability of agrarian community. The intended benefits are even more prominent, that they which include the increase in area under irrigation, increase in land productivity, and also the crop yield. If farm ponds are not lined, then there is groundwater recharge. Also, farm ponds help in securing yield of cash crops and horticulture, and therefore the monetary returns are assured. This eventually enhances the quality of life of farmers. Now we see and understand the study that we have conducted in 6 villages in the rain shadow area of Maharashtra. The map shows the location of 6 villages, which are situated in Sangamner block of Ahmednagar district. The picture on the right is taken on the field where we have gone. The characteristics of farm ponds is seen very much, that this farm pond is without inlet and outlet. It is lined with plastic material, which is impervious, and it is filled with groundwater. So these are the features of farm ponds in a study area. Also, I would like to mention that this farm pond is called as functional farm pond, as mentioned by local farmers. When there is a farm pond which is lined by impervious material, it is called as functional farm pond. This study was initiated in 2016-17, located in 6 villages of Ahmednagar. There were a total of 188 farm ponds constructed at the time, out of which 68 farm ponds were functional These were owned by 61 households. The table shows the categorization of farm pond sizes across the landholding of farmers. So there are total of 23 large farm ponds, 34 medium farm ponds, and 11 small farm ponds. With the household level data, we have calculated the net crop area prior and post farm pond construction. The post farm pond crop data is for 2016-17, while the pre farm pond crop data is adjusted for calendar year 2015 and 16, since the farm ponds were constructed in different years between 2009 and 15. From the graph, it is very clearly seen that for summer and perennial crops, farm ponds are proven to be very beneficial intervention since there is an increase in area under crop cultivation, which provides you the assured irrigation facility. But also for Kharif and Rabi season, you can see there is a increase in area under cultivation, apart from securing their crops of Kharif and Rabi. So with this, I would like to invite my colleague Sarita so that she will continue with the slides.
Thank you, Ankita, and good afternoon, everyone. Until now, we have talked about the background of the farm ponds, the purpose and the benefits. Now it is time to look at the different scenarios of the farm pond that we have observed in the study area. So looking at the scenario 1, it talks about the simple farm pond, as you can see in the Google image on the left, in which the farmer is lifting water from the borewell and filling it in the farm pond. And the depth of the borewell is 154.2 meters. And the surface area of the farm pond is 841 meters square. And the total area under cultivation is 182 hectares. So the farmer in this area cultivates different crops such as bajra, groundnut, chickpea, and wheat. So this is the actual practice of farm pond observed in a study area where they have converted it into the storage tank. Now moving to the second scenario, as you can see in the Google image, farm ponds are adjacent to each other and the source is nearby. So in this case, the owner one has 2 farm ponds, whereas the other owner has only single farm pond. And as a water source, both the farmer use borewell to fill in the farm ponds. The total area under irrigation of both the farmer is 2.85 hectares. As you can see in the schematic diagram, borewell 1 and borewell 2 are owned by owner 1, whereas borewell 3 is owned by owner 2. So, and the depth of the borewell is 106.7 meters. So when the borewell 1 is used to fill the farm pond, it creates a cone of depression, as you can see in the diagram we have shown it, which has an influence on the borewell 2 with regards to water fluctuation. We have validated this by doing the pumping test. Now in the scenario 3, this is the huge farm pond, which is about 1 acre in size. And this farmer uses 3 sources of water to fill his farm pond. What he does, he pumps water from both the bore wells and store it in the dug well. So this dug well is a storage well, as you can see in the diagram. And from this dug well, he lifts water and fills his farm pond. He has total area of 15.38 acres, and out of which 8.10 hectares are under horticulture, where he grows mango, pomegranate, custard apple, where the other are the seasonal crops. So on the right hand side is the elevation profile, in which you can see that due to the huge size of farm pond, large quantum of water is lifted. And if the aquifer continues to the downstream village boundary, then the impact of pumping will eventually affect the downstream aquifer. But the intensity of impact is still unknown, which requires a depth study to decipher the subsurface condition. Moving to the fourth scenario, this farm pond is located at a higher elevation in the village 1, and it draws water from the dug well 1, which is located in the downstream village. So the distance from the dug well to the farm pond is approximately 636 meters. And this farmer has almost 4 dug wells that is located in the downstream village. And he also have horizontal dug well, which taps the surrounding water. So we have found that in this village, there are deepest dug well that is 27.4 meters. So this farmer, in order to fill the farm pond, he has to lift water against the gravity, which requires a lot of investment cost and energy consumption. So this was about the different scenarios. Now, as you can see, so in order to fill the 68 farm ponds, total 87 water sources were lifted. In the pie diagram, as you can see, there are 40 bore wells, 39 dug wells, and 8 streams. And the table above, we have categorized the farm pond in 3 categories like large, medium, and small. So in order to fill the 23 farm ponds, there are 13 dug wells, 16 bore wells, and through 3 streams, the farm ponds have been filled. Whereas the small farm pond has a volume of 6,148 meter cube, and 13 dug wells, 9 bore wells, and 1 streams are being used. And there are also 13 horizontal wells we have observed in the dug well. Now we will have a closer look at the investment cost. So to construct the farm pond, the government provides funding through different schemes. So in the table, as you can see, we have categorized it in 3 different categories. So almost 91% of funding is done by the own fund, whereas only 9% is done by the received from the government scheme. And the total investment cost is approx 2 crores 80 lakhs. Thank you.